Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about some questions based on continuity of functions. Okay, so I am writing down the question number 1 here, which is we need to check whether the find all points of discontinuity. Now we need to check at what points the function is discontinuous. So the function given to us as fx is 2x plus 3 and 2x minus 3, and 2x plus 3 is when x is less than 2 and when x is greater than 2. So student, this is a similar sort of problem that I have discussed in my previous lectures also. Okay, so in this the solution goes very easy when you draw the graph of this function. Okay, so one function is defined at x less than 2 and one is defined at x greater than 2. Okay, so this is the critical point, or you can say at this point we need to check the whether the function is continuous or not. Okay, so for x equal 0 the function will give us 3. So this function is like, you can say this, and at x equal to the value of the function is 2 comma 7. Okay, so here the function is defined at x equal to 2 and x greater than 2. So at x equal to 2 the function taking the value 1. So here, and this function is parallel to this function. So this is 2x plus 3 fx equal, and this is fx equal 2x minus 3. Okay, so the critical point student here is 2. So we need to check the limits of this function only at x equal to 2, and rest all other points the function seems to be continuous, as you can see also from the graph. Okay, so I will check the left hand limit first. So limit x tends to 2 minus is, so the left hand limit at 2x plus 3 is like limit h tends to 0 2 of 2 minus h plus 3. So this is comes out to be 4 minus 2h plus 3, which is limit h tends to 0 7 minus 2h, so it is 7. And the right hand limit is limit h tends to 0 plus, you can say that, and the function defined here is 2x minus 3. Okay, so 2 times 2 minus h minus 3, so which is limit h tends to 0 4 minus h minus 3, which is 1 minus h, so it is coming out to be 1. So as you can see students, it is 7 here and the right hand limit is 1. So the limit is not equal, so we can clearly say that the function fx at x equal 1 is discontinuous. This we were able to see from the graph also. Okay, and from the limits we have clearly defined that. Okay, now let us move to another question. So students, here is question number 2 given to us, which states that show that the function f defined by fx is equals to mod 1 minus x plus mod of x. So we can do this, we can check the continuity of this function using two composite functions. Okay, using the concept of composites function. So I will start with define g by gx like what is given to us inside. Okay, and h by hx as mod of x. So I can say that h of g of x is hgx, okay, which is 1 minus x plus mod x. So I have put the value of gx and h of function is mod of this. Okay, so as we know that this function is also continuous and this function is also continuous, hence g is a function, or you can say the total net function h of g of x is a continuous functions. Okay students, so in this way also we can check the continuity of the function. Okay, so I hope that you are pretty clear on this, and in the next lecture student we will start with differentiability. Okay, so stay tuned for next lecture on differentiability. Thank you.